In 1985, a man in Akron, Ohio, bought a Maytag top loader. It had a mechanical selector switch, an electromechanical relay board, and a steel transmission with steel gears. That machine ran for 26 years. His daughter bought a Whirlpool front loader in 2019. It threw an F7 error code in year 4. The repairman came out, looked at the control board, and said 5 words that are costing American families billions of dollars every year. It is not worth fixing. Those 5 words are the subject of this investigation. We have spent months going through CPSC recall records, federal court filings, Department of Energy regulatory documents, and repair industry data. We have cross-referenced teardown reports from iFixit, technical analysis from Northgate Appliances, and repair forum surveys involving hundreds of technicians across the country. What we found is not a run of bad luck. It is a system. And once you understand how the system works, you will never walk into an appliance store the same way again. Here is what happened to your washing machine. Before 2007, the brain of a washing machine was not a brain at all. It was a mechanical timer, a physical device with gears and cams and copper contacts that clicked through the wash cycle one step at a time. When it wore out, and it eventually did, a technician unscrewed the panel, pulled the timer, installed a new one for $40, and left. The machine ran for another decade. The repair made sense. The math worked. Then the Department of Energy issued its efficiency mandates. The water standards required a dramatic reduction in water consumption per cycle. The old machines used 40 gallons or more per load. New efficiency requirements pushed that figure down toward 13 or 14 gallons. The energy standards mandated improved efficiency outcomes, and manufacturers turned to variable speed motors to achieve them. Those mandates were real, the engineering consequences were real, but what happened next was not inevitable. It was a choice. To meet the efficiency targets, manufacturers needed variable speed motor control. Variable speed control requires electronic inverter circuits. Electronic inverter circuits require a circuit board, and a circuit board, unlike a mechanical timer, can be shrunk down, automated, and manufactured in China for $20, then marked up to $350 when it fails and you need a replacement. They call this progress. We call it the most profitable component failure in the history of home appliances. The specific part is called the main electronic control board. In the industry, it is the ECB. It is a surface mount printed circuit board, FR4 epoxy substrate, lead-free solder made from tin, silver, and copper, populated with resistors, MOSFETs, capacitors, and a microcontroller that manages every function of the machine. It runs your spin speed, it reads your water level sensor, it controls the inverter drive on your brushless motor. Without it, the machine is an expensive plastic tub on legs. And here is where the engineering crime begins. This board lives behind your top control panel, or mounted at the back of the cabinet. In that location, it is exposed to laundry room temperatures that cycle between cool and 160 degrees Fahrenheit every single load. It sits in a humid environment. It absorbs vibration through the cabinet every time the drum spins. And it is assembled with lead-free solder, a change mandated by the European Union's RoHS directive in 2006 that is significantly more brittle under thermal cycling than the leaded solder it replaced. What that means physically is this. Every time you run a load, the board heats up. Every time it cools, the solder joints contract. Over 4 to 7 years and 200 loads per year, those joints micro-crack. The MOSFETs that control the motor inverter fail from power surges. The capacitors swell and burst from the heat, and one morning you come downstairs and the machine is sitting mid-cycle with the drum full of water and a blinking error code on the display. LG shows you UE or FE. Whirlpool shows you F7. Samsung shows you its own proprietary code that requires the manufacturer's diagnostic app to interpret. The technician arrives. He reads the code. He checks the board. He gives you the estimate. The board itself costs $250 to $350 at retail. The manufacturing cost, based on component analysis, is $20 to $30. The markup is structured not to cover the cost of the part, but to make the repair economically irrational. Add $300 to $500 in labor. You are now looking at $500 to $900 in total repair costs on a machine you bought for $700. A survey of repair technicians on the Appliance Repair Forum in 2023 found that 80% of them recommend replacement when a control board fails. Not because the machine is fundamentally broken, because the pricing makes repair impossible. This is not a coincidence. This is a business model, and it does not stop at the control board. Because while the electronics are failing in the control panel, the mechanical components below are engineered to fail at approximately the same time. The sealed drum bearing is the second component in this story, and it is arguably more dishonest than the first. On the machines your parents owned, the drum bearing was a replaceable cartridge. It was pressed into the rear of the steel tub, held in place by a circlip or a retaining nut, and accessible with standard tools. When it wore out, and bearings do wear out, that is physics, not failure, a technician removed it in 30 minutes and pressed in a new one for $20. Done. Beginning around 2006, manufacturers across the industry simultaneously transitioned to sealed drum designs. The drum bearing is now bonded permanently into a plastic outer tub assembly. It is not serviceable. It cannot be removed without destroying the tub. When the bearing seizes, and it will seize typically between years 5 and 8, the repair estimate looks like this. The bearing itself costs $20. The sealed tub assembly that contains it costs $350 to $400. Labor to disassemble the machine, swap the tub, and reassemble runs $250 to $300. Total, $600 to $700. On an $800 machine, the repairman says it is not worth fixing. He is correct. The machine was designed so that he would have to say that. The outer tub in most modern front loaders is also made of plastic rather than the porcelain-coated steel used in earlier machines. Plastic tubs are lighter, which reduces the energy required to spin the drum, which helps the manufacturer meet the efficiency mandate. Plastic tubs are also cheaper to produce and faster to assemble. The 4 to 6 minute per unit assembly targets documented at major manufacturing facilities require components that snap and clip and bond, rather than components that are bolted and welded and serviceable. The Whirlpool Corporation acquired Maytag in 2006 for approximately $1.7 billion in equity value, with the total transaction including assumed debt reaching roughly $2.6 billion. They cut 4,500 American jobs and shifted production to Mexico and other lower-cost facilities. Whirlpool's own 10K filing from 2025 lists their laundry segment as generating 35% of their revenue from repeat purchases. They are not selling you a washing machine. They are selling you the first machine in a replacement cycle that they have engineered to continue forever. Whirlpool has faced numerous CPSC recalls between 2015 and 2025. Among them, one recall covered over 1 million washers for fire risk caused by electronic control board arcing. Samsung issued a recall covering approximately 663,000 top loaders for fire risk related to overheating and short-circuiting. LG faced a class action lawsuit, Krupp vs. LG Electronics USA Inc., Case 2-20CV00625, in the District of New Jersey, covering defects in their front loaders. Whirlpool settled a class action in Ohio for $15 million in 2022. These are not the outcomes of bad luck. These are the outcomes of a component selected for its cost, installed in an environment that will destroy it, and priced to ensure that when it fails, you replace the machine rather than repair it. Now add the gatekeeping layer on top of the hardware failure. Even if you wanted to repair the board yourself, the control boards in many modern machines are potted in epoxy. The circuitry is physically encased in a resin compound that prevents access to individual components. To reflow a failed solder joint, or replace a swollen capacitor on a modern SMD board, you need a hot air rework station that costs $500 or more, plus the diagnostic skills to locate the fault. Samsung has introduced proprietary firmware locks that prevent third-party control boards from being programmed to work with their machines. OEM parts are required. Whirlpool's diagnostic procedure requires a proprietary service dongle that costs over $100 and an active subscription to their diagnostic platform. LG and Samsung lock their service manuals behind dealer portals that independent technicians cannot access without manufacturer authorization. The right to repair movement has been fighting this structure in federal hearings since 2021. Several states have pursued legislation mandating parts and manual availability. Though as of this writing, appliances remain largely outside the scope of past right-to-repair laws, most of which have focused on automobiles and consumer electronics. The manufacturers have lobbied successfully to keep the walls up, and the workforce is disappearing behind those walls. Industry observers report significant job vacancy rates in the appliance repair trades. The diagnostic complexity of modern machines, the proprietary software, the sealed components, the epoxy-potted boards, has made training longer and the work less economically rewarding for a young technician entering the trades. Private equity firms are buying local repair companies, keeping the name on the truck, and converting service calls into replacement sales pitches. The skilled tradesman who could look at a machine and tell you exactly which component failed and why is becoming genuinely rare. In 10 years, he may be gone entirely. So, if the machine is designed to die and the repairman is being designed out of existence, what do? You stop buying the touchscreen. You start buying the motor. There are specific machines that every honest repairman will tell you about. Machines that are not engineered to fail. And one of the most recommended right now is the Speed Queen TR7. Speed Queen is manufactured by Alliance Laundry Systems in Ripon, Wisconsin. Alliance is a private company. They do not answer to Wall Street's quarterly margin targets. They build commercial laundry equipment for laundromats, hotels, and hospitals. Machines that have to run 10,000 cycles in environments far more abusive than your laundry room. The TR7 is their residential top loader. It features electronic controls, heavy-duty drum bearings, and a stainless steel tub. It has a belt that costs $20 to replace. Alliance has tested it to approximately 10,000 cycles, and the company describes it as built for 25 years of life in the average home. The TR7 carries a 7-year parts and labor warranty on the complete machine. With a lifetime limited warranty on the stainless steel tub, the TR7 costs between $1,500 and $1,900. That is more than a Whirlpool from a big box store. But the 10-year total cost of ownership, accounting for the 1 to 2 replacements and repairs the Whirlpool will require, runs approximately $2,500 for the mainstream machine versus $1,700 for the Speed Queen. The machine that costs more up front costs less over the life of the household. If $1,500 is not your number right now, the second option is a pre-2006 Maytag top loader in clean used condition. These machines have mechanical selector switches, electromechanical relay boards, and steel transmissions. Every component is accessible with a standard screwdriver. Parts are still available. A used unit in working condition costs $400 to $800. If it is under 20 years old, it has 10 or more years of remaining life in it. It will outlast the machine sitting next to it on any showroom floor. If you must buy new at a mainstream price point, Craftsmanship Magazine and repair technicians consistently point to the simplest Amana top loader. No digital display, no Wi-Fi, no touchscreen. The simpler the control interface, the fewer the electronic failure points. The fewer the electronic failure points, the longer the machine lives. The rule is this: every feature is a failure point. Every screen, every sensor, every Wi-Fi connection is one more component that the machine does not need to wash your clothes and that will eventually prevent it from doing so. Your grandmother's washing machine was loud. It was heavy. It was not smart. It ran for 30 years. Yours is quiet, has a touch screen, connects to your phone, and will be in a landfill in 6 years. Stop buying the marketing. Buy the machine that the repairman puts in his own home. Buy mechanical. Buy simple. Buy repairable. And if you already own a machine from before 2007 that still runs, do not replace it. It is worth more than anything you can buy new today. Maintain it, repair it, and run it until the wheels fall off. Because unlike everything on the showroom floor, it was actually built to last. The best washing machine is the one that never needs the repairman. The second best is the one he can actually fix.